Hello, everyone. My name is Kevin Tarr. I'm an iOS engineer, and today is officially day 20 of Algorithms with Swift. So I'm not going to dance this time. I'll probably save that for maybe day 30, our last day. Maybe. Who knows? I might extend it, like I said. But today, we're going to be focusing on identifying missing numbers within an array of that supposedly is supposed to have elements 1 to 100, but there are going to be numbers missing within that array. So this is going to be an interesting solution. We're going to try to solve this without a for loop, and which will make it even more intriguing and interesting and fascinating. And I can't wait to get started. So let's go. So our problem states create a function that accepts an array of unsorted numbers from 1 to 100, where 0 or more numbers might be missing, and returns an array of the missing numbers. We have some test cases here. If your argument was created like this, we have an array of numbers 1 to 100 right here, and you remove the number at index 29, index 19, index 9, you will return 10, 20, and 30 because arrays are 0. So 9 will be equal to 10, 19 will be equal to 20, 29 will be equal to 30. Okay? So I'm going to give you guys, and mind you, I don't necessarily want to do the for loop solution, but I want to just show this just for teaching sake. But the for loop, we can do the for loop function first, which is computationally expensive. It is order n complexity because we have to go through every single number within the array. And then I'm going to give you the one-liner that is constant time, or order n constant time, order 1 complexity. So let's begin. So I'm going to call this missing. Passing in an array of integers. A return an array of integers. I'm going to create another array called missing numbers. That's what we're going to stuff our missing numbers into. That's the array we're going to put our missing numbers into. Then we're going to create a constant of numbers 1 to 100. Okay? Then we're going to for loop through it for I and 1 to 100 if array does not contain I. If array does not contain any number from 1 to 100, add that to the missing numbers array. Okay? And then at the end of the function, you just return whatever is in the missing number array. Okay? Simple, straightforward enough. Okay? Now to get our missing number array, we're gonna up here above, before we call this function, we're gonna create an array of 1 to 100. We're gonna create a constant of excluded numbers that we want to be excluded from this. So it's going to be 10, I'm going to do 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And then I'm going to filter throughout the original array and say if array, let me just show you. Filter excluded numbers. So basically, the excluded number does not contain any element. If the excluded number does not contain any number within the array, then put that in the new array. Okay, so basically, take out all the excluded numbers out of the original array and give us that back. Okay, so let's see, print filtered array. Let's do this really quickly. Let's see what we get. Okay, so you can see that 10, 20, 30, and so on and forth are missing. All these numbers are missing out of the array. Okay, so that's what we should get when we actually try to identify our missing numbers. So if we pass in this filtered array, it should tell us all the numbers that are missing within within this array that from 1 to 100. And in fact, we'll print this out before we return. So give us all missing numbers. And let's comment this out so it doesn't confuse us. Boom. So these are all the numbers missing from 1 to 100 within our array. Okay, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, so this is valid. It's just computationally expensive. We have to run contains 100 times in order to get all the missing numbers out of an array. What we can do is do this in a much more efficient, time-efficient, constant time way by using sets. And we can actually do this in one line of code, okay? So we call this missing numbers again. We pass in the same array, return an array of integers, and then just say, since we'll convert this into an array, and then say set array dot subtracting set set array 1 to 100 subtracting set array, and that should give us all of our elements. Oops. Okay. Let me first make sure this works. Okay, let's print this out. Let's I'm gonna just make this 2 lines just to show you guys how it looks. Below. Oh, sorry, got the print. That's what I was doing. Missing numbers. So, okay. Boom. Okay. So these are all missing numbers, albeit they're unordered, but they're missing. They're missing nonetheless. You know, we can sort them if sorting really is to your fancy, but this becomes a bit more computationally expensive with sorting. But sets are still pretty lightweight and still a better solution if you want to sort it or whatever. And but you know, as I said before, it's the same thing. You can do this in one line of code with just putting this in a return statement right here. This solves the line. This solves the entire function. Okay. Yep. There you go. Sorted. And if you really, and just to test edge cases, it's always good to check to see if the array is empty. So just check to see if the array is empty before you do all this work. Let's return nil. You can create this as an optional, the return element as an optional, and return nil if the array is empty. And if the array is not empty, then go ahead and do this problem, okay? And this is just tested for edge cases and just being safe so the computer doesn't do extra work that doesn't have to do. So this solves our problem, guys. Let me know what you guys think about this problem. I think this is a pretty efficient solution. One line and very, very computationally inexpensive to solve this problem. Hope this helps you guys in your coding interviews. If you ever get asked this question, remember the solution. My name is Kevin Tarr. Have a good night. Signing out from day 20. Bye, guys.